All right, Algebra 1A students. Welcome to part 2 of lesson 4.2. Today we're talking about linear functions. In our last video, we started representing relationships between quantities in 3 different ways. We used tables and graphs and words or sentences to describe what was happening to quantities. And we're going to do kind of the same thing here in this video. But in this video, we're talking about something a little bit more specific than just a relationship between two variables. Okay, a specific kind of relationship is called a function. Okay, and a function is a relationship that pairs each input value with exactly one output value. Okay, so every value you input has to come out with exactly one output value. Okay, so if I have a table of values over here, let's say I've got x as my inputs and I have y as my outputs. If I do this, 1, 2, 3, 2, and I go 4, 5, 7, 9, this is not a function, because x equals 2 has 2 different y values with it. See this? X equals 2 has 2 different y values that it goes with. So that's not a function. Okay, a function has to pair each input number with exactly one output number. So this is not allowed right here. We cannot repeat x values if we're going to have a function where we pair every x value with exactly one y value. Okay? A linear function is a function whose graph is a line or part of a line, which basically means for a linear function, the y values increase or decrease by the same amount, always. Okay, that's the key for linear functions. Please make sure that this gets written in your notes somewhere, that a linear function has the y values increasing or decreasing by the same amount every time, always, no matter what. Okay? The types of problems that you're going to see in your practice problem set look like this, where you'll be given a table of values or some other sort of situation, and you'll be asked this question: is the relationship a linear function? Is it a linear function? And then describe it using words and a graph. Once again, your problems are going to say an equation. We will not do the equations, however. Okay, we will do words and a graph. So if we look at this table that they give us here, it's about photography, where we're taking some photos and we have an amount of memory on our memory card here. So what we have to look at is, as my photos go up by 1, what happens to the memory in my memory card? Well, 512 down to 509 is minus 3. And then the next time I take a picture, 509 to 506, I go minus 3. And then the next time from 506 to 503, I go minus 3. Okay? So what we should notice here is that the y values are decreasing by 3 every single time, the same amount every time. So that fits our definition of a linear function. So the first thing that we say here is yes. Yes, this is a linear function, absolutely. Okay? And now they want us to describe what's happening with words and then with a graph. Well, in words, we should be able to see from this table that each time we take a picture, we lose 3 in our memory card. Right? In this case, it's 3 megabytes, actually. 3 MBs in our memory card. Okay? So that's what's happening in words in this relationship, in this function. Each time we take a picture, one more picture, we lose 3 megabytes in our memory card. So that's words, and now they want me to make a graph for them, which we've been practicing in our last few videos, right? We make 2 axes like this. Along the bottom, we're talking about how many pictures have we taken, and then along this side, we're talking about how much memory do we have left, okay? And now I'm going to start maybe at call that 500 on my memory. Then I'll go 502, 504, 506, 508, 510, 512, 514. That's high enough. So I'm just counting up by 2s, starting at 500, so that's 504, and so on and so on. And then I'll mark off a 1, a 2, and a 3 on the pictures, because my first point obviously is 0 pictures, which will be way back here. That's 0 pictures right there. Okay. Now I'm going to plot some points that I see in this table, because they gave me the table. I don't have to work at all at that. Now I just have to plot my points. So when I have 0 pictures taken, my memory is 512 megabytes. So at 0, which is going to be right here, I'm going to go up 500, 502, 4, 6, 8, 10, 12, right to here. And there's my first point of this graph. Okay, there you go. When I go up to 1 picture, now I drop down to 509, which for me is going to be halfway between 508 and 510, because I go 500, 502, 4, 6, 8, and then up to 10 will be right about there. So that's where this dot is. The next one comes at 2 pictures and 506. So I'll go up to 2 pictures, you go 500, 502, 4, 6, right about there. And then my last one is at 3 pictures and 503. So 500, 502, almost to 504, but not quite. Right about there is this dot. Okay? So we can see these blue dots keep going down as I take more pictures. So I've now given them words and a graph. I just put a title on here. Memory after pictures, I'll call it. Memory after pictures. Okay? So I told them, yes, this is a linear relationship because I keep going down by 3 each time. I then described the relationship using words right here, just a sentence, and then a graph right here where I give them a title, 2 labels, and some points on my axes. Okay? I got one more I'd like you to try doing these same kinds of things. Everything except an equation. We're not going to worry about the equations until later on in this chapter, or actually in the next chapter, really. Okay? But I want you to tell me, looking at this table, is this relationship a linear function? And then describe it using words and then a graph. Okay? So pause the video for a couple minutes, take a look here at this table and decide. And then come on back once you've decided and I'll show you what we should have. The answer is most certainly yes. This is a linear function because my y values, my output values here, continue to go up by 2, up 2, up 2, up 2. Okay? So that's what I would say in my words. I would say for every 1 increase in my input, I increase 2 in my output. Okay? So there's my sentence, there's my words describing this situation. And now I'm going to make a graph, which we should make, again, with 2 axes like this. On the y-axis, I'll count by 2s, 2, 4, 6, 8, 10, 12, 14, 16, 18, 6. And then on my x-axis, I'll count just 0, 1, 2, 3. Obviously this, I don't know, it's just my y, it's my output axis. And then down here, I have my x-axis. Here's my x-axis. There's no real good title here, but I'll just call it inputs and outputs. And now I will plot points. So at 0, my point needs to be up at 8. So 2, 4, 6, 8. Remember, 0 is right along this line on the y-axis. When I'm 0 in my input x values. When I'm at 1 in my input, I'm up at 10, which is right here. Just up a couple more. When I'm at 2, I'm up at 12, which is just up a couple more. And then when I'm up, at 3, I'm up at 14. Okay. So I've given words, I've given a graph, and the answer is absolutely yes, this is linear because it's always plus 2, and so on, plus 2. Okay, if you have questions at all about going from a table, deciding if something is linear or not, and then giving me words and a graph, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.